This is a GCSE physics presentation on density. To get started, there's an iceberg with a volume of 100 meters cubed. Will the same volume of water have more mass, less mass, or the same mass? And how do you know this? Spend a minute, try and come up with an answer, and whenever you're ready, you can restart the presentation. So pause now. Well, if we take the same volume of water, ice will actually float on top of water, hence in the picture you can see ice on top of the water. And the reason for that is because if we have the same volume of ice and the same volume of water, you will actually find that the same volume of water has more mass than the same volume of ice. And I say, how do we know this? It's because of the observable phenomena of ice actually floating on top of water. In this presentation, we are going to look at the concepts of mass and volume. We're also going to introduce what's called a Eureka can, and we're going to look at the calculation for density. When we talk about volume, we talk about three-dimensional space that any particular substance takes up. When we increase volume, we're simply saying that it takes up more space, that particular substance takes up more space. And often to increase volume, we can add more particles of a substance, or we can space those particles that are already there further apart and increase the amount of space. What is the standard unit for volume? Well, the standard unit for volume is meters cubed. You have to remember the 3 should be above the m. It can't be beside or below. It has to be superscript. In terms of measuring volume of objects, if we have a regular object, for example a cube, we can simply do the length times the height times its depth. If, for example, the cube on the right hand side was 2 meters long, x, y, and z will all be 2 meters. So to work out the total volume, you would simply get 2 times 2 times 2, which would give us a total of 8 meters cubed. If, however, we have an irregular shape, one that's not cube-like and not easily measured, we have to use a different technique for measuring the volume. And what we do is we can simply submerge that particular object into water, and the water displacement shows the volume of the particular object that we put in. So if you look on the right hand side, we have a before and after image of a measuring cylinder, and what you have to do is work out the volume of the little crown object that's been placed into the water. Pause the presentation to give yourself 2 or 3 minutes to have a go at it. When you're ready, you can restart. Well, remember, when reading anything in a measuring cylinder, the curvature at the top of the liquid is called a meniscus, and we always read from the bottom of the meniscus. So what we should do is the before value is 7, the after value is 12, which gives us a difference of 5. So the volume of the object that we've placed in the liquid is 5 meters cubed. Now we can do a similar type experiment using what's called a Eureka can. And Eureka can is simply a metal can with a little funnel. And how it works is you fill the funnel inside the Eureka can right up to the edge of the funnel with this maximum amount of water. You must get it at level, and you must get it as perfect to that opening as you can. When you place your object into the Eureka can, the water level rises, and the water level rises and pours out the drain. You can then wait until no more water comes out of the little drain of the Eureka can, and the water that's present in the beaker outside has the water that's been displaced by the volume of the object you put in. So whatever water pours out of the Eureka can represents the same volume as the object you put into the Eureka can. Now another value we're going to need to measure is mass. Remember, mass is measured in kilograms, and we have to measure kilograms. We use a balance. Remember, when writing kilograms, we have to use a lowercase k and a lowercase g, do not put a capital K for kilograms when using the symbol. You can, of course, use capital K for kilograms at the start of a sentence as you would with any sentence, but we don't use a capital K when writing kg. Now there's a question. If different substances had the same number of particles, would they have the same mass? Well, quite simply, no, they wouldn't, because different substances are made up of different types of particles. And because there's different types of particles, all the different types of particles have their own different masses. So you would not get different substances with the same mass, or certainly very unlikely to. So then we come to the term density. Well, density is a measure of the mass of a substance, so how many particles we find, per unit of volume, so in a specific amount of space. So we talk about the number of particles, we're talking about its mass, and we're talking about how far out those particles are spread, we talk about the volume. So there's two objects, objects A and B. Have a look, which object has the largest density? Well, in actual fact, both densities of those objects will be exactly the same, because object A has 5 particles, object B has 10 particles, but object B has twice the volume of object A. Therefore, the densities of both of those objects will be exactly the same. We can talk about densities and we can tie it to the concepts of states of matter. As we heat up a solid into a liquid and a liquid into a gas, particles become more spread out. As they become more spread out, they increase in volume, which means that the same volume, the green square, you can see that you have fewer and fewer particles as you heat that substance up to become a liquid, and then as you heat it to become a gas, there are fewer number of particles, the mass, inside the same volume. And as a consequence, when you heat substances up, as a general rule, the density of the material will become lower. So as you go from solid to liquid, liquid to gas, the density will decrease. Now, is ice more or less dense than water? Well, if you remember back to the start, we said that ice actually floats on top of the water, so the ice is less dense than the water, even though it's a solid. And as a consequence, ice and water are one of the things that don't follow that general rule. So when calculating density, you get the mass divided by the volume. Now density is a symbol. That symbol is not a letter P, it's actually the Greek letter rho. So you need to be able to use the equation density equals mass divided by volume. Remember that you also need to be able to rearrange the equation because they could ask you to calculate the density, the mass, or the volume. And when rearranging equations, we use Smurf's simple method for understanding a rearranging formula. Make sure you know how to rearrange formula using any method, but Smurf's is the one I would suggest. And you cover up A, B, or C depending on what you want to work out in a triangle, and it tells you what you do with the other two numbers. A divided by B equals C. A divided by C equals B, or B times C equals A. And just to finish off, you've got a 2-minute challenge. You have to talk about what's been covered in this particular presentation for 2 minutes. First repetition, pause, mistake, you have to start again, and you can talk to a family pet, a family member, a mirror, yourself, or anybody or anything that will listen.